All right, this lesson is on systems of equations. Let's start with this system. X plus y equals 5 and 2x minus y equals 4. And we want the solution to this system, and that would be the x and the y that work for both equations at the same time. I happen to know that the solution is the ordered pair 3, 2. And here's how you would verify that 3, 2 is actually the solution of this system. If I plug it into the first equation, x plus y equals 5, and that's my x, that's 3, plug that in there, and my y is 2. Notice that that works. 3 plus 2 is 5. It also works for the second equation. If I plug in 3 for the x and I plug in 2 for the y, that's 6 minus 2, that equals 4. So 3, 2 works for both equations, therefore it is the solution of the system. Now, how do we get the solution? Because I just gave you that it was 3, 2. Well, there are various ways to do that. The book mentions 3 of them. The first method that they talk about is called the graphing method. And so what I'm going to do is graph each line. So let's graph. Well, I'll write graphing method here. Two, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6. First line, x plus y equals 5. The x-intercept is at 5, 0. The y-intercept is at 0, 5. And this line, properly graphed, looks like that. You guys should be fairly good at graphing lines by now. The second line, 2x minus y equals 4. The x-intercept is at 2, 0. And the y-intercept is at negative 4, 0, negative 4. 1, 2, 3, 4, right about there. And sketching the line, it looks something like, not the best line here, but that'll do. There it is. Now, if you graphed your lines accurately enough, you would notice that the two lines intersect right here at the ordered pair 3, 2. And that's how we get the solution of the system. The intersection of the two lines is the solution to the system. The downside of the graphing method to get the solution is you got to be very accurate. If you're not, then you might get the wrong ordered pair. Well, let's try another one like this. Let's take 2x plus y equals negative 5, and negative x plus 3y equals 6. So once again, I'm going to use the graphing method to get the solution. The first line, right there, has an x-intercept at negative 2.5, and it has a y-intercept at 0, negative 5. And it looks something like this. The second line has an x-intercept at negative 6, right about there, and a y-intercept at 2, 0, 2. And it looks something like that. Okay. And if we graph these accurately enough, we should be able to identify the intersection point here, and it should be at negative 3, 1. And there's the solution of the system. Now, if you're not sure, you could, like we did before, we could plug that in and check. So I guess I better do that here. Let's check and make sure that negative 3 comma 1 is actually the solution. It's got to work for both equations. 2x plus y, is this going to equal negative 5 if I plug in this x and y in here? Yes, that adds up to negative 5, so that works there. The second line, or second equation, is negative x plus 3y equals 6. If I plug the negative 3 in here and the 1 in there, that will, two negative signs, 3 plus 3, yes, it adds up to 6. And so we do have the correct solution, negative 3 comma 1. So like I said before, with the graphing method, the solution is where the lines intersect, but you got to be very, very accurate to actually get that. Here's one other. Let's say we have x plus y equals 3, and we have y equals negative x plus 5. So we're going to graph each line again. The first line has a x-intercept at 3, 0 and a y-intercept at 0, 3, like that. The second line is in slope-intercept form. It has a y-intercept at 5, and the slope is negative 1 over 1, so down 1 over 1, down 1 over 1, and so on, and would look like something like that. There we go. These lines turn out to be parallel. If you check, the slopes are equal. We have parallel lines, and so we will have no intersection. Well, if you have no intersection, then you cannot have a solution. And so, since these lines are parallel, this system has no solution. Or your book may write it as the solution set is empty. Now, there really are only 3 different things that could happen when you graph 2 lines. If you graph 2 lines, they could, as these 2 lines do, they could intersect somewhere. One intersection, and therefore you would have one solution. We would say that this system is consistent. Call it a consistent system. The other case that we just saw is it is possible that your 2 lines could be parallel to each other. Let me see if I can fix that. Blue there we go. Parallel lines, no intersection, therefore the system will have no solution. We call this sort of system inconsistent. There is one other thing that could happen when you graph 2 straight lines, and that is you could graph one line and then graph the other line, and it turns out that they are identical. Now, identical lines, I guess you could say, intersect everywhere. And so they have many intersections, and therefore you would have infinitely many solutions. Infinitely many solutions. Since it does have a solution, it's got lots of them, we would say that this is consistent system, but since the lines are identical, what we say is that they are dependent system. Okay, and that's all that can happen when you graph 2 lines. You can't have one line curving around another one and then have 2 intersections. Not going to happen. One of these 3 cases. Now, let's talk about the substitution method. do a couple examples of that. Let's take the first example that we did, x plus y equals 5 and 2x minus y equals 4. Now the substitution method works like this. We take one of the equations and we solve for one of the variables, and it doesn't matter what equation, doesn't matter what variable, just pick whatever seems easy to you. And I think it's rather easy to solve this top equation for y, so I'm just going to write y equals, what would that be, 5 minus x, right? You move the x to the other side. Okay, now you take the second equation, or the equation you haven't used yet, and I'm going to substitute. I have up here y equals 5 minus x, so I'm going to replace this y in the other equation with 5 minus x, which would look like this. 2x minus y equals 4, and this y is being replaced with what's equal to 5 minus x. Now what this does is it creates an equation for me that only has one variable in it, and I can now solve for that variable. So let's do that. 2x, I got to distribute the negative sign. Excuse me. The negative sign. Negative 5 plus x equals 4. 3x will equal 9, and x will be 3. So I got x. X is 3. You also, of course, need the other variable y, and the easiest way to get that is to use this equation back up here. Y equals 5 minus x, and so y must be 5 minus 3, which is 2. And so using the substitution method, we have found that the solution to the system is 3, 2. Here's another. (7x minus 2y equals negative 2, and y equals 3x. Now, one of the equations here is already solved for a variable right here, and so I'm going to use that fact to save myself a little time. Let me rewrite the second equation down here. Since y equals 3x, I'm going to replace this y right there with 3x, and that would look like this. 7x minus 2y equals negative 2, and that y gets replaced with what is equal to 3x, just like that. I now have an equation with only x's in it, and so I can solve for x. This will be 7x minus 6x equals negative 2. 1x equals negative 2. I found x. Now all I need to do is find y, so I'll go up and use this equation. Y equals 3 times x, which is negative 2. Y must be negative 6. And so the solution to our system is the ordered pair negative 2 comma negative 6. If you aren't sure that you did it right, you could always take the solution that you found, the ordered pair you found, and plug it into the two equations just to make sure that they work for both. Let's try one more using the substitution method. 5x minus 3y equals negative 6, and x equals 2 minus y. Okay. Once again, this equation down here is solved for a variable for us. It's x equals 2 minus y. So what I'm going to do is I'm going to take the other equation, rewriting it, and since x equals 2 minus y, I will replace this x with what it's equal to, 2 minus y. Notice that in the previous two examples we replaced y, but in this case we're replacing x. (5) x minus 3y equals negative 6. This x gets replaced with 2 minus y. I now have an equation with only y's in it. I can now solve the equation. That'll be 10 minus 5y minus 3y equals negative 6. 10 minus 8y equals negative 6. Subtract 10 from both sides. Negative 8y equals negative 16. And if I did that right, I think y should be 2 here. Y equals 2. Yeah. Okay, now I need x. So I'll use this equation that solves for x already. X equals 2 minus y. But we just found that y is equal to 2, so 2 minus 2 is 0. X must be 0. So the solution to our system, the ordered pair 0, 2. There it is. This means that 0, 2 works for both equations. It also means that if I were to take the time to graph the two equations, the two lines would intersect at precisely 0, 2. Now let's look at one of these. Let's look at that case where we had parallel lines. I believe it was x plus y equals 3, and then we had y equals negative x plus 5. Okay. And we graphed this system previously, and the lines were parallel, and so we had no solution. Watch what happens if I try the substitution method to solve the system. Since y equals this, I'm going to take the top equation and replace y right there with negative x plus 5, which would look like this. Negative x plus 5 goes right in there. Now, if I attempt to solve this for x, what happens is the x's cancel away, and we end up with 5 equals 3. All the variables disappeared, and you ended up with something which, of course, is not true. So, 5 does not equal 3. This is what's called a contradiction. It's not true no matter what x is. And so this means that we do have no solution here. No solution. So anytime you get something ridiculous like that, where all the variables cancel away, 5 equals 3, 0 equals 1, 8 equals 8, something like that, or 8 equals 7, something that's not true, where all the variables disappear, that's when you have no solution. That means that the lines are parallel. The lines are parallel to each other. Okay. Now, we've talked about the graphing method, the substitution method, but those aren't the ones that are actually used most often. The most often used method is what's called the elimination method or the addition method. Depending on what book you have. And it works like this. Let's take this example, 3x minus y equals negative 7, and 2x plus y equals negative 3. We have to have our x's and our y's lined up, and we do have that here. And if you notice, if you draw a line and you simply add vertically, the way things are right now, the y's would cancel away. 3x plus 2x is 5x. But negative y plus y is 0. This is gone here. It's a 0 there. And that right side adds up to negative 10. So I've just added vertically. The y's disappeared, and now this allows me to solve for x. 5x equals negative 10, then x must be negative 2. Okay, very quickly I got x. Now to get y, what you can do is take your x value and plug it in to one of the original equations. It doesn't matter which one you use, just pick whichever one you prefer to work with. I'll use this one right here. If I plug in negative 2 for the x, let me fix that. If I plug negative 2 in here and work that out for y, I get negative 4 plus y equals negative 3. Switch back here. Y equals 1. And I found x, I found y. The solution of the system must be the ordered pair negative 2 comma 1. And once again, if you're not sure that you got it right, you can always take that ordered pair and plug it in, make sure it works for both equations. Here's another one. (2x plus 3y equals negative 6). 4x minus 3y equals positive 6. Now once again, if I add them together just the way they are, conveniently the y's once again cancel away. 3y and negative 3y is 0. So I got 6x here, and over here I got 0. 6x equals 0, divide both sides by 6. And this is x equals 0. Once again, I take a equation. I'll just pick the top one here. Plug in the 0 for x, which will allow us to solve for y. Put that in there. And we end up with 3y equals negative 6. Y should be negative 2 here. Solution of the system 0, comma, negative 2. 0, negative 2. Now, things don't always cancel like this that easily. For example, let's look at this one. X plus 3y equals 8. 2x minus 5y equals negative 17. If I add them just the way they are, nothing cancels away, and so it's not going to do us any good. What I have to do first here is multiply an equation by something, and I'm going to get the x's to cancel away in this case. Since this is a 2x, I need this up here to be a negative 2x, so I'm going to multiply both sides of this equation by negative 2. I'm going to rewrite each one. The top equation up here becomes negative 2x minus 6y equals negative 18. That was this one right here. Rewrite the second equation. You haven't really altered this one at all. And you end up with that. Okay, so by multiplying the top equation through by negative 2, I can now eliminate x's when I add the equations together. Adding the two equations together, the x's are gone now. Negative 2x and positive 2x is 0. Negative 11y, and this is negative 33. Divide by negative 11 and we have y equals positive 3. I've got y. Now I need x, so I'll pick one of my equations. I'll pick this one right here. Plug in 3 for the y. And we end up with, for x, we should end up with negative 1. Negative 1. Solution of the system, negative 1 comma 3. Negative 1 comma 3. Here's another example of one where you have to multiply by something first. (5x minus 2y equals 4). 2x plus 3y equals 13. Once again, if I add them just the way they are, nothing's going to cancel away. So I have to multiply by some constants here. Now I am going to eliminate this time the y's. I'm going to get rid of y's. You could get rid of x's if you want. It doesn't really matter. Now since this is a negative 2y and that's a positive 3y, I could easily turn each one of those into 6y. I'll multiply the top equation through by 3, both sides, the whole thing. That'll give me a negative 6y up there. And if I multiply the bottom equation through by 2, that'll give me a positive 6y. Let's rewrite each equation. 26. Okay. Now if I add them the way they are, we got 19x. The y's will disappear. And over here we've got 38. And 38 divided by 19 is exactly 2. I've solved for x. It is 2. Now I need y. Pick any equation you want with y in it. Doesn't matter. I'll take the very top one, the original. And plug in 2 for the x. And you end up with y is positive 3. Did I do that right? 10, move it over. Yeah, that looks right. Solution of the system, 2, 3. 2, 3. Okay. Just one or two more examples here. Okay, let's solve by using the elimination method. To get the x's to cancel away, I'm going to multiply the top equation through by a negative 2. Rewrite each one. Oh, I goofed up. I am not supposed to multiply through by negative 2. I need a positive 2, don't I? My mistake. Let's fix this then. Multiply through by a positive 2, so this is a positive 2x. This is a positive 6y, and this is a positive 8 over here. That's better. Okay, now if I add the equations together, the x's will cancel away, but also the y's cancel away. And you end up with no variables at all here. You get a 0 on this side. And that equals 18. Or 11. 0 equals 11, which obviously is a contradiction, a false contradiction. And we learned earlier that if all the variables disappear and you end up with something which is obviously not true, this means that this system has no solution. In other words, those two lines, if you were to graph them, would be parallel. Parallel lines. One more example. (2x plus y equals 6). Negative 8x minus 4y equals negative 24. Now, if you try to get the y's to cancel away, what you would have to do is multiply the top equation by 4. That would give you a 4y here and negative 4y there. So let's rewrite those equations. 8x plus 4y equals 24. Negative 8x minus 4y equals negative 24. And if you add everything up, everything is gone, and you end up with 0 equals 0. Well, 0 equals 0 is true. True statement. And when all your variables cancel away and you end up with something which is true, like 0 equals 0, 5 equals 5, 10 equals 10, then this is the case where you have identical lines. Identical lines. The book would say that the system is what's called dependent, and you have infinitely many solutions to the system. What are the solutions to the system? Formally, the way that you are supposed to write it is, the solutions to the system are all of the x's and y's that satisfy one of the equations. So you just pick one of them because they're really the same equation. If you notice, one of them is just the other multiplied through by a negative 4. And it's all the x's and y's that meet the requirement 2x plus y equals 6. Okay, so This is how the book may ask you to write the solutions. Usually I just ask for that, infinitely many solutions. Okay, and that is our lesson on solving systems of equations.